Alright, so let's come to the equation of a circle. Just as a quick reminder, if the center is at 0, 0, then there's nothing here next to the x or the y that are going to shift that center of the circle. So that comes from the Pythagorean theorem, a squared plus b squared equals c squared, but we're going to call that x squared plus y squared equals r squared. Now the reason that we're doing that is because this is the horizontal change for x and this is the vertical change for y equals the hypotenuse squared, or the radius of our circle squared. So the graphing form for a circle, the equation of a circle, is the quantity of x minus h squared plus y minus k squared equals r squared. Now our locator point, or our center, is hk, just like it was for the absolute value and for our quadratics. That's still the h and k, but notice that both of these are negative. Okay. And our radius is r. Alright, so now let's go through some examples. So I've got x squared plus y squared equals 16. Now there's nothing here with the x, nothing here with the y, so the center is at 0, 0. And then this is r squared, so we have to take the square root of 16, and our radius is 4. Okay. So the center is at 0, 0, and the radius is 4. Now for this next one, we have something shifting with the x, but nothing is changing the y. So it's moved to the right 1, so that center is at 1, 0. And once again, the square root of 25 is 5, so its radius is 5. So this has a center at 1, 0, and a radius of 5. And this last one has shifted to the right 3 and down 4. So it has a center at 3, negative 4. And then the square root of 36 is 6. Now on those last examples, I had the radius always was a nice number, but it doesn't always have to be a nice number. Okay. All right, so on this example, it's shifted to the left 3 and up 5, so the center is at negative 3, positive 5, and then the radius is the square root of 31. Now normally when we do the square root, we do the positive and negative, but we're talking about a radius, and that's a distance. It's the distance that's away from the center, so we only have to do the positive of that. All right, now in example 5, it shifts to the left 5 and down 2, so its center is at negative 7, negative 2. Another way that you can kind of look at this is that we're taking whatever signs are inside here and changing them. So it was plus 7, so this is a negative 7. It was plus 2, so this is a negative 2. And on this last example, it's subtracting 4 inside with the x, so that's a positive 4. And it's subtracting 1, so that's adding 1. And then the square root of r squared, so that's the square root of 15. All right, so those are some examples where the radius does not turn out to be a nice number. All right, so those last examples, you were given the equation and then we figured out the center and the radius from the equation. But you can go the other way. If I give you the center is 3 and 2 and the radius is 5, the equation of the circle, we know that the h and k comes from our center and that r is the radius. So we just have to put those values in. So this becomes the equation for the circle that has a center at 3, 2 and a radius of 5 is x minus 3 squared plus the quantity of y minus 2 squared equals 5 squared. And then we would want to simplify this side so that it's 25. Okay? So that's x minus 3 squared plus y minus 2 squared equals 25. All right, here's another one. We're told that the center is negative 2, 5, and it has a radius of 2. So the equation would be x, instead of saying minus a negative 2, we're going to say x plus 2 squared plus y minus 5 squared equals 2 squared. And 2 squared is really just 4.